All these lines are actually wires. Wires are used to connect terminals, indicators, functions, and SubVIs together. Think of a wire in a LabVIEW program exactly the same as you think of a wire on an electrical circuit. For the case of circuits, it's used to carry information in the form of current and voltage. In LabVIEW, it's used to contain information of various different data types. If we hover over a SubVI, we see a list of all of its terminals. We see that the joystick port wire is connected to the joystick device input of that SubVI. And the joystick dev ref is this thick brown wire that comes out and then into the left side of the joystick get. Not all terminals have to be wired all the time. You see in the joystick get SubVI, the scalar input is not used, but the joystick dev ref is. Also notice that the axes output is a thick brown wire here. If we hover over that wire, we see that it's actually called a cluster. Clusters in LabVIEW are used to combine multiple different types of data together. In this case, the cluster contains 6 different axes, but as you can see here, the next function that's used is called unbundle by name. It's being used to pull data out of the cluster, and it's only pulling out axis 1 and axis 2. Then we see that a thin orange wire is used to connect the axis 1 value to the X horizontal bar indicator. The axis 2 value is connected to the Y horizontal bar indicator. And then we have some additional functions which are being used to combine the X and the Y data together and then put it on the XY graph. And these functions are called bundle and build array. In this way, the individual X and Y data are put in the right format necessary for the XY graph. The other thing to notice is that inside the while loop, all this information gets connected over and over and over again. To observe that, let's turn on this function here called highlight execution and then run the program again. Highlight execution is a very useful tool for debugging your code. What it does is shows little bubbles along all the wires as data is flowing from function to function to function, or from controls to indicators. Again, the code is deployed onto the target, and once that's complete, we'll see the code executing with execution highlighting turned on. So observe that data first flows from the joystick port to the joystick open, and then the while loop starts, and the code inside the while loop begins running. So observe that the values coming out here are 0 and 0. And the dot on our XY graph is positioned at 0 and 0. If I move the joystick controller, the values change. And also take a close look at the stop terminal. We see here that the value each time through is false. That's allowing the loop to continue running. However, if I push the stop button, the next time through the while loop, the value will be read to be true, which will cause the loop to stop, and then close the joystick and stop communication with the driver. So what we've just done is take a look at the execution of a LabVIEW program while it's running. A couple of important things to point out that are very fundamental to the way that LabVIEW code runs. Observe that the joystick port and the start communication part of the program ran first. Then the code in the while loop continued to run over and over and over again. Then the code inside the while loop ran, and not until the stop button was pushed did the close joystick reference and the stop communication function run. The reason for that is called data flow. Data flow is the method that LabVIEW uses to determine what happens in what order. In other programming languages, code is written in a text-based language sequentially. In other words, things that happen higher in the program run first. Things that are lower in the program run later. In LabVIEW, the decision as to what runs first is based on the position of wires. There's two fundamental components to data flow. The first is nothing will run until data is at its inputs. In other words, the while loop cannot run until after the joystick open is complete, because joystick open has this wire as its output. The second basic principle of data flow programming is that data does not come out of a node until it's finished. In other words, see this wire here? This is an output of the while loop. But it doesn't come out until the while loop is finished running. In other words, the while loop will keep running until the user pushes stop. But these two functions, because they have wires connected to the output of the while loop, will wait until the while loop is finished. This concludes the first of our series of introductory LabVIEW videos intended for the FIRST Robotics team members and mentors. Hope you found this useful. Please take a look at our second installment where we take the same example and modify it to work with 2 joysticks. Thank you very much for watching this video. There have been several pop-ups throughout this video which, for subscribers of the lvmastery.com online training, will drill you right into the training material relevant to that particular section. Remember that these introductory videos are intended to get your feet wet and get you introduced to LabVIEW. There's lots to learn about LabVIEW, and we're very proud of the lvmastery.com online learning experience. We've had a lot of great feedback from other FIRST team members and other high school students who have taken the training. I'd also like to mention the Buy One, Give One special offer for mentors, teachers, and parents associated with FIRST teams. We're allowing anyone who's associated with the FIRST team to purchase the LV Mastery online training for the academic price of $500 for all 3 courses. And for anyone who takes us up on that offer, we'll donate a training seat to a member of their team as well. Thank you very much for watching. This has been Ben Zimmer from lvmastery.com. Bye for now.